Today we're going to be adding and subtracting rational expressions. Your essential question is, how do I find the least common multiple or the least common denominator? So LCM is the abbreviation for least common multiple, and LCD is least common denominator. So if you see those, that's what they're referring to. So first we're going to talk about finding the least common multiple. So when you're finding the least common multiple, let's talk about if we were doing that with regular numbers. So if I was trying to find the least common multiple of 4 and 12, for instance. Okay, multiples are different than factors. So multiples are when you say, like, you skip count by that number. So the multiples of 4 would be like 4, 8, 12, 16, and then you'd keep going. Okay, and then so for the multiples of 12, I would start with 12, and then I would have 24, and then I would have 36, and so on. So when I find the least common multiple, I'm finding the smallest one that they both have, which would be 12. Okay, now when we do this with polynomial expressions, it's kind of the same thing. 12 is made up of 4 times 3, and this 12 is made up of 12 times 1, which can be broken down into 4 times 3. And so they both have the same factors or the same things. So when we're doing this with polynomials, it's very similar. So if you were to think of these expressions as completely factored, for instance, 5x cubed is made up of 5 times x times x times x. Okay? And if I factor 10x squared minus 15x, the greatest common factor would be 5x. I could take that out. And then I would have left over 2x minus 3. So this is what these two expressions are made up of, like the factors of those expressions. So if I'm trying to find the least common multiple of these, then what I'm going to do is I'm going to say, what do they both have? It's almost like finding a common denominator. And so this one has a 5x already, and this one has a 5x already. So now I need to say what's missing from this one and what's missing from the other one. So this one has the 5x, but it's missing the 2x minus 3. So I would have to multiply this one by 2x minus 3. And this one has the 5x, but it's missing an x and an x, which would be like x squared. Okay, so if I bring all the parts together, then I would have 5x, because that's what they both have, and then I would need to add on an x squared and a 2x minus 3. So they would both end up having 5x cubed altogether, 5 times x times x times x, and 2x minus 3. And that would be the least common multiple. So if I took all the parts from both things and combined them all together, that makes up the least common multiple. So let's try another one. So let's say we have 4x squared minus 16 and 6x squared minus 24x plus 24. So I need to factor these to see what they're made up of. So first I always check to see if there's a greatest common factor. So on this one, the greatest common factor would be 4, and I would have left over x squared minus 4. Now you should notice that x squared minus 4 is a special type of polynomial. It's a difference of squares, so that can be factored further. So that would factor down into 4 times x plus 2 and x minus 2. Because we can take the square roots of both of these numbers and we get 2 and 2 and x and x. So we have to have one of each sign to make it work out. Now this one, the greatest common factor would be 6. And so then I would have left over x squared minus 4x plus 4. And this is a general trinomial, which can be factored. So we were looking for factors of 4 that add to be negative 4. And so then we would get negative 2 and negative 2. So that would be x minus 2 and x minus 2. Oh my goodness. So if I look at both parts now, they both have an x minus 2 kind of in common. Okay, and if I look at the numbers, I have 4 and I have 6. So if I think of multiples of 4, I have 4, 8, 12, 16, and so on. Multiples of 6, I have 6, 12, and that's the one that they have in common. So I know for my answer I'm going to have 12 in there because that was the least common multiple of the numbers. I could multiply this one by 3, and I could multiply this one by 2 to get the 12. So they would have to get the 12. This side is missing an x plus 2, so I need to make sure that they both have that. And they already both have an x minus 2. And then, so I need to include that because that's what they both have. And then this side needs another x minus 2. So this side also needs another x minus 2 because we have to have 2 of them if there's more than one. And this side we said just needed the 2, and then we also needed an x plus 2 because this one didn't have one. So when you're talking about the least common multiple, you're trying to find out what they are missing and combine all the parts together. So if I combined both of these things together, I would have 12 because that's how I'd make both the numbers the same. I would need an x plus 2. I would need an x minus 2. And then this one already had an x minus 2, but I would need another one. So it would have another x minus 2. So this would be the answer. Okay, now I know that's kind of difficult, but when we're adding and subtracting, finding the least common denominator is actually, I feel, a little bit easier than finding the least common multiple, even though they're relatively the same. So when you're finding either the least common multiple or the least common denominator, what you need to look for is what's missing from each one, and then combine the two together. So when I'm adding or subtracting rational expressions, it's just like when I'm adding or subtracting regular fractions. If I was to take 1/2 plus 2/3, I cannot add fractions or subtract fractions without having a common denominator. So on this side, I would say, what would be the common denominator of 2 and 3? Well, I could multiply this side by 3 because that's what's missing. And I could multiply this side by 2 because that's what's missing. So then I would get 3 over 6 plus 4 over 6. And now, because they have the same denominator, I can add them together. So it would be 3 plus 4, which would be 7 over 6. So it's just the same thing with polynomials. You find the common denominator, and sometimes you have to factor first to do that. Then you just either add or subtract the numerators, and then you reduce if you can. So it's the same thing. So we're going to try doing this. So we're going to have 7 over 9x squared plus x over 3x squared plus 3x. So first, you always check to see if you can factor anything. And remember, there were 5 or 6 different types of factoring that we talked about. So you can refer back to that sheet if you're stuck on the factoring portion. So what we're going to do from here is we're going to find the common denominator by factoring first. Well, the 7 and the 9x squared are all the way factored. There's not anything I can really do there. The x is already factored. There's not really anything I can do with that. But on this part, I can take out a greatest common factor. The greatest common factor would be 3x, and then I would have left over x plus 3. Now, 9x squared, if it helps you, is the same thing as 9 times x. So it's kind of the same thing. Sometimes it helps people to break it apart and then sometimes it helps them just by looking at this. So if I'm looking at my two denominators, I have 9x squared, and I have 3x times x plus 3. So I need to see what's missing from this side. Well, this side is definitely missing an x plus 3 for sure. This is not wanting to work for me today. So it's definitely missing an x plus 3. Okay, this side, I have to somehow turn my 3x into a 9x squared. So I would need to multiply by 3, and then 3x times 3 would give me 9x, but I need another x because it has to be 9x squared. So I'm going to multiply the top and the bottom of these by 3x. Oh, why keep doing that? Okay, so from here, I found my common denominator. I have 9x squared and I have x plus 3, and this side has 9x squared and x plus 3. So now I can just multiply this out and simplify it, because I asked myself what was missing from each denominator. I got that. So now I have to multiply it out and just see what happens. So if I take 7 times x plus 3, I would have to distribute that. So I would get 7x plus 3 over 9x squared times x plus 3. Now you don't have to multiply out the denominators, because even if you leave them in factored form, they're going to be the same, which was our goal. So it doesn't really matter. You should leave that alone. Okay. Then the top, if I take 3x times x, I get 3x squared. And then the bottom, 3x times 3x would be 9x squared, and then x plus 3. So now I have a common denominator. That's not going to go away. So now all I have to do is just add the numerators. I should say add the numerators to get the answer. So if I take 7x plus 3 times 3x squared, or not times, plus 3x squared, I can't combine any like terms. So the 3x squared would just come first, and then I'd have plus 7x plus 3, and then over 9x squared times x plus 3. Okay, so that would be the answer. Now remember, when you add fractions normally, you have to try to see if they can reduce. So what we can do to try to see if this reduces is we can actually factor the top portion. And this type, because there's an x squared in front, I would have to do AC method. So 3 times 3 would be 9. But there are no factors of 9 that add to be 7. So this would be the final answer because it could not be factored or reduced. Okay, let's try some subtraction ones. So same thing. The only difference is we're subtracting. So again, we have to factor everything that we can. Well, x plus 2 cannot be factored. 2x minus 2 could be factored. And you're probably thinking, how can I factor that? It's pretty simple. Well, remember, you can always take out the greatest common factor. So if I take out a 2, then I would have left over x minus 1. Okay, then on this one, negative 2x minus 1 doesn't have a greatest common factor, so that just has to stay the same. And then x squared minus 4x plus 3 is a general trinomial. So I would look for factors of 3 that add to be negative 4, which would be negative 3 and negative 1. So this would be the factored versions of what we started with. So now we have to find a common denominator. Okay? Now remember, to do that you say what's missing from each side. Well, this side has a 2 and an x minus 1. It's missing x minus 3. So we definitely have to multiply by x minus 3. And this side has the x minus 1, but it doesn't have the 2. So we're going to multiply this side by 2. And then you can double check, because you can say, okay, do they all have the same parts? This side has a 2, this side has a 2. This side has an x minus 1, this side has an x minus 1. This side has an x minus 3, this side has an x minus 3. And then you know that they're going to be the same. So now I can go ahead and multiply it out. So, and I'm going to, because this is x plus 2 and this is x minus 3, I have to double distribute to work it out. Okay, so x times x would be x squared. I'll do this out to the side. Then x times 2 would be 2x. Then I have negative 3 times x would be negative 3x. And then negative 3 times 2 would be negative 6. Then I can combine the middle. So I get x squared minus x minus 6. And then the bottom can stay in factored form, because I just wanted to make sure they all have the same parts. And it really doesn't matter what order you write the numbers in. Okay, then if I distribute the 2 to this, then I would have 2 times negative 2x would be negative 4x, and 2 times negative 1 would be negative 2. All over, and then I would have the same denominator as the other side. So now that I have a common denominator, I can subtract the numerators. So I'm just going, I already simplified, I'm going to subtract the numerators. So when you think about this, remember, it's like x squared minus x minus 6, that's one quantity, minus negative 4x minus 2. And so when you're subtracting, you have to really either watch your signs or you can do the keep, flip, change. So if we just watch our signs, we would have x squared, there's nothing to combine it with. And then I would have negative x minus negative 4x, would be like adding. So negative x plus 4x would be positive 3x. And then I have negative 6 minus negative 2, which would be like adding again. So that would be minus 4. Okay? Or you could do the keep, flip, change. You do keep, flip, change both of these. So I have x squared. I have negative x plus 4x, which is 3x. And I have negative 6 plus 2, which is negative 4, which seems a lot easier to me. So I like to do the keep, flip, change on all the subtraction ones. And so this right now would be our answer. Now remember, you can always check to see if you can factor and reduce. So we need to check to see if we can do that. So once we've subtracted the numerators, that's up here. Okay, then I'm going to see if I can factor this. So I need to find factors of negative 4 that add to be 3. Well, that would be negative 1 and positive 4. So if I factor that, then this is what I get. So then I can look, oh look, my x minus 1s actually cancel out, so I actually could reduce this one. So then I'm left with x plus 4 over 2 times x minus 3. And that would be the final answer. So make sure to go back and answer the essential question and write your summary.